Hi guys, welcome to the YSB channel. So this video is a compressed lecture about percent yield, theoretical yield, limiting, and excess reactant. So this might help you in your review kung nagre-review ka for your summative test in chemistry. So I will just give a short introduction later and then we will proceed agad po sa pagko-compute or pagsosolve ng mga ganitong problems. So I hope that you have your calculator, your periodic table, your pen, and your paper with you. Okay, so let's start. What we're going to do is we are going to calculate percent yield, theoretical yield of the reaction, and medyo konting explanation about the concept of limiting reagent and excess reagent. Okay. So, bakit may mga gantong topic tayo? Kasi sa laboratory po, di ba, if may mga tinatawag tayong pagsisynthesize ng compounds. May mga experiment yan, ganyan. And merong chemical reactions na nangyari when we conduct those experiments. Parang ganyan. So, if you are familiar with chemical equation, di ba meron tong reactant side, tapos it yields to, tas may product side. Ganyan, di ba? So, ang goal natin is makapag-produce tayo ng maximum amount ng product dun sa chemical reaction natin. Yan. Kasi kapag syempre mas madaming product na mapoproduce, ibig sabihin, mas malaki yung profit, mas malaki yung kikitain ng kumpanya kasi mas madami silang mabebenta na product, right? And also, magiging greater efficiency siya for the chemist kasi ibig sabihin, wala masyadong losses during the reaction. I mean, the reactants are fully consumed, fully na-maximize natin yung paggamit nung or pagsisynthesize natin ng mga compounds natin, okay? So, one can theoretically compute for the amount of products formed in a given reaction. That's why, yun yung i-compute din po natin later. Okay, so let me just give you a short definition about limiting and excess reactant. So, when we say limiting, di ba, from the word itself, limit, siya yung nagbibigay ng boundary dun sa reaction na kapag naubos siya, wala ka ng product na ma-form. 'Di ba? Kasi syempre, sa reactants, kailangan kumpleto yung reactants mo. Pag nag-react na sila, yun yung makakapag-produce ng product mo. Di ba? Parang ganyan. So, a limiting reactant is the reagent that is completely consumed at the end of the reaction. So, as I was saying, sa madaling salita, pag naubos na yung isang reactant na to, wala nang mapoproduce na product. So, another thing na i-take note po natin is yung word na reactant, ayan, itong reactant, and also yung word na reagent are interchangeable. So, kapag sinabing hanapin natin yung limiting reagent, yun din yung limiting reactant. Or hanapin natin yung excess reagent, yun din yung reactant. Okay? So, wag tayo ma-confuse doon. So, excess reactant naman, of course, from the word itself, excess. Siya yung merong natira. Okay? May excess siya. May sumobra sa kanya. So, this reactant is not totally consumed in the reaction. Okay? Ngayon, for example, let me give you a brief illustration. For example, if I want to make a bike. Okay? Ito yung gusto nating product. Magkaroon tayo ng bike. So, we need one frame and dalawang wheels to make a bike. Okay? So, in the concept of parang reactants and product, ganyan. So, sabihin natin na ito yung mga reactants natin, tapos ito naman yung product na gusto nating makuha. So, for example, if I have 5 na frame and 8 po na wheels, ilang bike kaya yung mapoproduce ko? Given na dapat sa isang bike, you need 1 frame and 2 wheels. Siyempre, ayusin natin. Try natin siya ayusin. So, siyempre, yung 1, 2, 3, 4, 5 frames, andyan sila. And yung 1, 2, 3, 4, 5, 6, 7, 8 na wheels, andyan din sila. Kaso, nakapag-produce lang tayo ng 1, 2, 3, 4 na bikes. And itong isang frame natin, wala na siyang kapartner na wheel. Meaning po, sa isang chemical equation or sa isang chemical reaction, yung magiging limiting reactant natin will be the wheels. Bakit? Kasi una silang naubos, kaya nung naubos sila, hindi na tayo makakapag-produce ng bike. Kasi itong frame na to, hindi mo naman masasabi na bike yan. 'Di ba? Pwede bang magtipa ka dyan, wala kang gulong, di ba? Hindi ka makakausad. So, yung frame natin, yun naman yung tinatawag natin excess reactant kasi po, merong sumobra sa kanya. Ngayon, ano naman tawag natin dun sa mga products natin or dun sa bike natin? Ang tawag natin dito is yung theoretical yield. Okay? Sila yung mga product. Sila yung maximum amount ng product na na-form natin with the given reactant. reactants. Okay po? So, yun po yung parang basic concept or basic illustration about limiting and excess reactant. So, now we are going to proceed with the other topic, yung actual yield and theoretical yield and percent yield. Ganyan. So, sabi ko sa inyo kanina, yung theoretical yield, nako-compute natin siya. Once na naubos natin yung limiting reactant, yung product natin, ang tawag natin doon is yung theoretical yield. Meaning, yung limiting reactant, siya yung nakakapag-produce nung theoretical yield. Kasi nga, naubos na siya, so hanggang doon na lang po yung reaction. Ngayon, ano naman po yung actual yield? When we say actual yield naman po, siya naman po yung nakukuha natin during the experiment talaga. Commonly sa problems ay given yan. Hindi natin siya nakocompute talaga. So, pag sinabi natin actual yield, from the word actual, ibig sabihin, during the laboratory experiment or sa the synthesizing ng mga compounds is, ito yung talagang nakuha natin. 'Di ba? Minsan, madalas pala, hindi pareho yung actual yield at saka theoretical yield. At lagi na mas mataas yung theoretical yield sa actual yield natin. Ganyan. So, iba yung nako-compute natin minsan dun sa actual na nangyayari kapag nag-e-experiment po tayo. Okay? So, ang ginagawa natin is, kinukuha po natin yung ratio ng dalawang yon, then minumultiply natin sa 100%, and we call that as the percent yield. Okay? So, mas madaming or mas malapit yung value nila sa isa't isa, edi syempre, mas mataas yung percent yield. Okay? Meaning, mas efficient din yung chemical reaction po natin. So, let's now proceed to the examples about the topics. But first, let me give you my own made steps, ganyan, about the topics or sa pag-solve ng mga ganitong bagay. Una is to write and balance the equation. Bakit write and balance? Dahil not always na given yung equation, not always na given a balance na equation. So, minsan, need mo i-analyze yung problem para makapag-create ka ng equation. Parang ganyan. Pangalawa is, I taught my class na we are going to list the given separately, reactant versus product. Para alam mo saan ka manggagaling, papunta dun sa, at saan yung pupuntahan mong product. Parang ganyan. Pangatlo is, you have to find the limiting reactant using theoretical yield, which is actually when yung ang mangyayari is given the limiting reactant, malalaman mo na, okay, dahil siya yung nakapag-produce ng mas lower na value, siya yung theoretical yield, which is mamaya natin mas mapapaliwanag yan. Pang-apat, in finding the excess reactant left over, compute for the amount of excess reactant actually used and get the difference between the total excess reactant and the excess reactant actually used. So, di ba may excess tayo, excess reactant, meaning sa excess may sumobra. So, minsan, hinahanap ng problem, gaano kadami yung natira dun sa excess reactant pagkatapos maubos nung limiting reactant. So, kinakompute natin yan. And take note of this, yung LO is made lang naming parang word para mas ma-represent natin yung excess reactant left over. Okay? So, let's now proceed to the practice problems. Okay, number 1. How many grams of PF5 can be formed from 9.46 grams of PF3 and 9.42 grams of XEF4? Also determine the limiting reagent. So as I've said a while ago is reagent, meaning siya din po yung limiting reactant. So interchangeable sila. So we are given a chemical equation, probably hindi natin alam if balance or unbalanced siya. So what we're gonna do is to make sure na balance yung equation. Okay? So let's try to put PF then XE. So we have here 1, 3, XE ay 1, tapos plus 4. Ganito kasi ako mag-balance ng equation. Ewan ko lang kung paano kayo mag-balance ng equation, no? Okay. So, nag-multiply tayo ng 2 here. Then, F3, nag-multiply din tayo ng 2. XE ay wala. So, 4. Then, 1 times 2, 5 times 2. Then, Xenon 1. Okay. So, let's see. 2, 6 plus 4, 10. 5 times 2, 10. Then 1. Okay, ibig sabihin, we have a balanced chemical equation. Hindi pa natin need na mag-isip masyado pa. Okay, so, ang unang-unang need natin gawin after natin i-write and balance yung equation is to write the given. Okay? So, yung given, as I've said earlier, is write it in a way na mas mapapadali kang mag-solve. So, write the reactant and the product separately. Okay, so sabi dyan, how many grams of PF5 can be formed from 9.46 grams of PF3 and 9.42 grams of XEF4? So, pansin nyo, PF3 ay nasang side siya, nasa reactant side. Si non-F4, so nasa reactant side din siya. So, ibig sabihin, itong mga given na to, yung 9.46 and 9.42, ay sa reactant natin ilalagay. So, let's put 9.46 grams of PF3 and 9.42 grams of XEF4. Then, ang sabi dyan is how many grams of PF5 can be formed. Meaning, ang target mo is mula dito sa given natin na sa reactant side is gusto mong mapapunta sila sa grams ng PF5. Nasaan si PF5? Ito po, nasa product side. Okay. Then, the next thing you should do, syempre, if you are going to make a gram-to-gram conversion, alam natin lahat, or if you have watched my video about mole conversion, hanapin mo na agad yung kanilang molar masses para mas mabilis ka nang makakapag-solve. So, let me give you the molar mass of PF3. Ang PF3 po ay 87.968 grams per mole. Then, si XEF4 ay 207.286 grams per mole. Then, si PF5 is 125.964 grams per mole. Okay. Once na, okay na, meron ka ng molar masses, may reactant and product side ka na. So, isa pa na need mong tandaan is yung mole ratio. Ayan. So, yung mole ratio, siguro, medyo alam nyo na rin to kung nanood kayo ng previous na lesson. So, mole ratio is, titingnan mo lang lagi yung mga coefficient nung nasa balance chemical equation natin. So, dito is, meron tayong 2 moles ng PF3. Ayan, 2 moles ng PF3 equivalent sa 2 moles ng PF5. 2 moles ng PF5. Ayan, 2 moles ng PF5. Also, 1 mole ng XEF4 is equivalent to 2 moles din ng PF5. So, these are the given na need natin para sa ating pagsasolve. Okay. So, proceed na tayo sa solution natin. Sana magkasya siya, no? So, for our solution, first is you need to start with the given. So, sabi dyan, ito yung given natin. Start muna tayo sa 9.46 grams PF3. So, punta tayo sa 9.46 grams of PF3. So, gram to gram conversion, if naka-grams yan, the next thing na dapat mong i-multiply sa kanya is dapat nasa baba is katulad din nung nasa taas. So, kung grams PF3 to, dapat grams PF3 din to. So, para magawa yun is, kailangan mong gamitin yung kanya pong molar mass, which is 87.968 grams PF3. So, sa taas niya is 1 mole ng PF3. Next is, syempre, makakancel mo to. Tama? Ngayong nakamole ka na ng PF3, gusto mong tumulay. Gusto mong tumulay dun sa pangalawang substance, which is yung PF5. So, tandaan nyo ba, ang bala kasi natin, mula dito sa mga grams ng PF3, papunta tayo sa grams ng PF5. Mula sa grams ng XEF4, papunta rin sa grams ng PF5. So, yun yung ginagawa natin ngayon. Okay? So, what we're gonna use here is the mole ratio, which is 2 moles ng PF3 is equivalent to 2 moles ng PF5. Okay? So, para makancel natin, ayan. Then, syempre, ang target mo ay mapapunta ka sa grams ng PF5. So, gamitan natin yung to ng molar mass ng PF5. PF5. So, ang molar mass po niya ay 125.964 grams of PF5. Since, andun na tayo sa gusto nating o desired nating parang result, ganyan, edi solve na natin siya. So, if you are going to compute this, you will get 13.546 grams of PF5. Okay. So, may isang value ka na, dun ka naman sa pangalawang given. So, the next given is 9.42 grams XeO4. 9.42 grams XeF4. So, multiply natin sa molar mass niya na dapat nasa baba yung grams XeF4. So, ang molar mass po niya is 207.286 grams per 1 mole ng XeF4. So, cancel natin yan. Then, para makatawid papunta sa PF5, you need to use their mole ratio. So, 1 mole ng XeF4 is equivalent to 2 moles ng PF5. Then, multiply din natin siya sa kanyang molar mass. 1 mole ng PF5, 125.964 grams ng PF5. Okay, so the answer here, if you are going to compute for this, is 11.449 grams of PF5. So, tandaan nyo ba, ang hinahanap natin is yung grams of PF5 na na-form at saka yung limiting reagent. Ngayon, ma'am, may dalawa kong value. Alin dyan yung tama? To get the theoretical yield natin tinatawag or yung totoong na grams ng PF5 na na-form natin, choose the lower number, which is itong 11.449 grams ng PF5. Meaning po, yung reactant na nakapag-produce sa kanya ng yung reactant na nakapag-produce ng lower number, that will be your limiting reactant. Sino yun? Ito po yun. Si XeF4, siya po yung ating limiting reactant. Okay? Meaning, unang naubos si 9.42 grams ng XeF4 bago naubos si PF3. So, ibig sabihin, itong PF3 natin, siya naman po yung tinatawag nating excess reactant. So, itong grams ng PF5 na na-produce, ito ay tinatawag nating theoretical yield. Okay, supposedly, ito yung maximum amount ng product na mapoproduce natin given yung 9.46 grams ng PF3 and 9.42 grams ng XeF4. So, yan. O, di ba? Nakapag-solve na tayo ng isa. Next problem, if you are going to ask, ma'am, ano po itong 13.546 grams PF5? Wala po yung kwenta. Kasi ibig sabihin, imposible siyang ma-produce. Ganyan. Bakit? Kasi nga, ubos na nga yung limiting reactant mo eh. So, dahil ubos na yung limiting reactant mo, hindi ka na makakapag-produce pa ng more PF5. So, ito ay wala siyang value talaga. Okay? Imposible siyang ma-produce. Next, how many grams of IF5 would be produced using 44.01 grams of I2O5 and 101.0 grams of BRF3? So, may binigay sa ating equation. But, let's make sure na ito po ay balance. Okay? Balance na chemical equation. So, I2O5 plus BRF3 then yields to IF5 then O2 plus O2 plus 10 BR2. Okay, so try natin if balance siya. IOBRF. So, given itong mga nasa taas, okay, meron daw 2 times 6, so 12 na I, tapos O is 30. BR is 1, F is 3, tapos sa IF5 is 12 yung I, okay, tama. Then, O is 2 times 15, then 30, tama din. BR is 2 times 10 will be 20, right? Then, F is 5 times 12, so ito ay 60. So, parang may mali, di ba? So, pag ganyan, guys, you need to make sure kahit may mga nakalagay ng coefficient sa unahan, make sure nyo na totoong, na tama talaga, balance talaga yung chemical equation. 6. So, try natin na i-balance to. So, since 60 dapat yung, BR must be 20. So, BR, lagyan natin ng 20 dito, probably. Multiply tayo ng 20. So, nag-multiply din tayo ng 20 dito. Okay. Now, we have a balance equation. Copy natin itong 12, then itong 15, then itong 10. Okay. So, now, balance na po yung equation natin. Next is magpo-proceed na po tayo dun sa ating lalagay ng given. So, lagyan ko lang siguro ng 6I2O5 plus 20 BRF3 yields 212IF5 plus 15O2 plus 10BR2. Okay, lagay na natin yung given natin. Sa reactant side, reactant. Given, reactant side natin po ay meron daw tayong 44.01 grams ng I2O5. So, 44.01 grams ng I2O5 and 100 grams of BRF3. 101 grams ng BRF3. Okay, ang goal mo is ma-convert siya sa ang product, grams ng IF5. So, ito lang yung consider natin, grams ng IF5. Okay, so ito yung hinahanap. How many grams ng IF5 mo produce? Okay, next is, of course, you need to put their molar masses or get their molar masses. So, let me give you their molar mass. Si I2O5 po ay 333.803 grams per mole. Then, si BRF3 is 136.8, ay sorry, 0.898 grams per mole. Then, IF5 is 221.894 grams per mole. Okay? So, yung mole ratio siguro wag na muna natin ilagay para lang hindi masyadong sumikip tong ano natin pagsa-solve natin. Okay. So, let's try to solve. Mag-start ka lagi sa given. Okay? 44.01 gram I2O5. Then, multiply natin sa kanyang molar mass. Dahil grams, I2O5 dapat yung nasa baba. So, ang molar mass niya is 333.803 grams I2O5. Then, 1 mole I2O5 yung nasa taas. Then, cancel to. Tapos, of course, pwede na tayong lumipat sa kabilang substance. So, 6 mole. 6 mole ng I2O5 papunta sa IF5. So, 12 moles ng IF5. Okay? So, cancel, cancel. Then, multiply natin siya sa ilalim yung mole ng IF5. Okay? So, 1 mole ng IF5, ilang grams ng IF5 to? 221.894 grams ng IF5. Okay. So, cancel natin to, cancel natin to. So, if you solve for this, it will be equal to 58.514 grams of IF5. Okay? Next. Ay, sorry. Next po ay next is yung pangalawang given, 101.0 grams BRF3. So, multiply natin sa molar mass niya, which is 136.898 grams BRF3. So, 1 mole ng BRF3. So, when we're dealing with molar masses, lagi niyong tatandaan na 1 mole lagi yung kasama niya. Yung grams is grams per 1 mole nung substance. Okay? Then, multiply natin sa mole ratio nila, which is 20 moles ng BRF3. F3 is and equivalent to 12 moles ng IF5. Okay? Then, multiply natin sa molar mass ni IF5, which is 221.894 grams ng IF5 all over 1 mole ng IF5. So, kahit tinatamad ka magsulat, so it's very important na alam mo yung how to write the right units, ganyan. Para hindi ka malito when it comes sa pag-solve mo po. Then, you will get 98.225 grams ng IF5. So, as I've said earlier, if you got two values, choose the lower one. Yun po yung tinatawag nating theoretical yield. Yun po yung grams ng IF5 na napoproduce talaga. So, ito yung theoretical yield natin. At yung reactant na nakapag-produce ng theoretical yield, ang tawag po natin doon ay limiting reactant. So, si I2O5, siya po yung ating limiting reactant. And ito naman si BRF3, siya naman po yung ating excess reactant. Okay? So, I hope clear na po sa inyo yung about sa limiting and excess reactant. So, let's proceed to this medyo higher kind ng problem. So, aluminum reacts with iron oxide to produce iron and aluminum oxide. Determine the percentage yield if 3.00 grams of Fe was produced when 3.50 grams aluminum was allowed to react with 5 grams Fe2O3. Okay. So, dito walang binigay na equation but we need to write the equation based dun sa given sa atin. Okay, so let's analyze. Sabi dyan, aluminum or Al, ayan, binigay na agad, reacts with iron trioxide. So, sa word pa lang na react, alam mo na nasa reactant side na siya. So, meaning, aluminum reacts with iron trioxide. So, mapalad tayo, binigay na agad, Fe2O3. Then, to produce meaning it yields to saan? Sa iron, Fe, and aluminum oxide, Al2O3. Ayan. So, ito yung chemical equation natin, pero hindi pa siya balance. Okay? So, let's try to balance this. Let's put, let's put 2 here. Yeah. Then, let's put 2 here. Then, ayan, okay na. I think balance na siya. 2 aluminum, 2 Fe, then 3 na oxygen. Okay, very good. Now, is we are going to write the given, which are, ano given natin? Una ay, okay, determine the percentage yield of 3.00 grams ng Fe was produced when 3 point. Okay, so, unahin natin yung reactants natin, yung given na reactant. Sabi dyan, 3.5 grams ng aluminum. Nasaan ba si aluminum nandito? So, lagay natin siya 3.50 grams ng aluminum kasi nasa reactant side siya. Then, to react with 5.00 grams ng Fe2O3. Okay. Ngayon, doon naman tayo sa product side. Okay. Si product naman, may binigay na 3.00 grams ng Fe. Ma'am, sino si 3.00 grams na Fe? So, ito pong value na to, once na may binigay, ito si Fe ay nasa product side. Once na may binigay na value sa product side, that is most likely the actual yield. Meaning, during the experiment, ito yung totoong nakuha natin. Okay? Hindi yan yung theoretical yield, siya yung actual yield. Yung nakuha natin during the experiment. Okay? Not the one that we computed kasi hindi pa naman tayo nagko-compute. Okay? So, meaning, ang goal mo is makuha yung theoretical yield. Bakit po? Theoretical yield. So, need mong makuha to kasi to compute for percent yield, you need to have the actual yield which is given na all over theoretical yield then multiply by 100%, right? Okay, so need mo talaga si theoretical yield. And ganun yung gagawin natin, kukunin natin si theoretical yield. So let's start with the given first. 3.50 grams ng aluminum. So hindi ko man sinulat yung molar mass. Ang molar mass po ng aluminum based dun sa periodic table ko is 26.982 grams of aluminum. 1 mole of aluminum. Multiply natin sa that mole ng aluminum yung nasa ilalim para makancel natin. So, tatawid na agad tayo. Based dito sa ating equation, we have 2 mole ng aluminum, then 2 moles ng Fe. Okay? Then, 1 mole ng Fe, tapos, ano pa ba? Ang grams po ng Fe is 55.845 grams of Fe. So, if we are going to cancel the units, yan, cancel. And this will be equal to 7.244 grams of Fe. Okay. Next is yung pangalawa, yung 5.00 grams ng Fe2O3. Multiply natin sa grams ng Fe2O3, dapat yung nasa baba. So, molar mass niya is 159.687 grams ng Fe2O3 1 mole ng Fe2O3. Nakakapagod pala to, no? Then multiply to 1 mole ng Fe2O3. Then 2 moles ng Fe. Ayan, tumawid na tayo using the mole ratio. Then 1 mole ng Fe. Ilang grams siya? 55.845 grams of Fe. Okay? So, pag na-solve natin to, syempre cancel muna natin yung units natin. Ayan. So, I hope maalam na kayo para mabilis na natin ma-distinguish yung gram to gram conversion. No? Okay. So, this will result to 3.497 grams of Fe. So, compared dun sa isang nakuha natin, 7.244 grams ng Fe. So, this is the lower value. So, this is our theoretical yield. Theoretical yield. Ito talaga yung na-produce natin during the reaction. At ang limiting reactant natin is itong Fe2O3. Okay? Siya yung nakapag-produce ng lower value kasi. Okay. So, hindi pa yan yung final answer natin. Ba't ko ba binaksan? So, what we're going to do is to get the percent yield. So, sabi ko kanina, yung actual yield natin is 3.00 grams. 3.00 grams of Fe. So, pansin nyo, grams ng Fe din to. So, 3.497 grams of Fe times 100%. So, lagi yung tatandaan, si actual yield ay mas mababa sa value ni theoretical yield. Okay? So, ito talaga dapat yung mapoproduce natin. However, syempre, during the experiment, hindi naman exactly na 5 grams talaga ng Fe2O3 yung meron tayo, di ba? May mga konting, ano yan, parang deviation dun sa value. And also, may mga losses, probably, malay nyo, during the chemical reaction, may konting natapon, ganyan. So, hindi natin na-produce yung 3.497 grams ng Fe na desired natin. Okay? So, ito talaga yung na-produce natin during the reaction. Now, to get the percent yield, this will be equal to 85.788%. Ayan. So, yung iba pong problems is dun na lang po sa next video natin para hindi po masyadong humaba. And that's all for this video. You can click the next one for the other problems. Thank you po.